Welcome to Maths with EJD. In this video, we continue with binomial series, actually looking at special cases and common pitfalls. In this particular video, our focus is on tricks for quickly calculating binomial coefficients. Now, let's go along. When we started out the whole idea of binomial series, the first thing we talked about was Pascal's triangle. And like I said, that really works for very small powers of n. I mean, very small values of n. That is the power, right? So you can use Pascal's triangle to find n. You can use Pascal's triangle to find n combination k values directly. So instead of having to do the whole binomial expansion thing, I mean, instead of doing combination to find that, you can just use Pascal's triangle. If the values are very small, the power of n is small. So use Pascal's triangle to find n combination k values directly. So for instance, the the fourth row, that is when you starting from n equals 0, starting from n equals 0. We did that a lot when we started out. So the fourth row will be the fourth row is 1 4 6 4 1. So and this actually is representing the coefficients of 1 minus x raised to power 4. We started by talking about 1 minus x, expanding 1 minus x raised to power n, right? So in case you did not follow when I did the other one, in case you have not seen that video, probably this is your first video. When we have 1 minus x raised to power 0, like I said, you're going to have 1 like this. That's raised to power 0. If you have 1 minus x raised to power 1, then it becomes like, so this one. Okay, I guess I have to make it closer so I can have some space. So you have 1 minus x raised to power 1. So Pascal's triangle simply tells you drop 1, drop 1. Then if you now have 1 minus x raised to power 2, then Pascal's triangle says drop 1, 1 plus 1, 2, then drop 1. Okay? Then if you have 1 minus x raised to power 3, so you drop 1, 1 plus 2 is 3, 2 plus 1 is also 3, drop this one. Then if you have 1 minus x raised to power 4, which we just talked about, so that's where you have all the 1, 4, 6, 4, 1. So that means drop 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, then drop 1. Okay, so we can go on like that. And the whole idea of Pascal's triangle is what is simply this idea that you see these numbers are forming something like a triangle now. So if you look at it, it's given like the shape of a triangle. And that is where the whole idea of Pascal triangle stems from. Okay. So what we have referred to up there is actually this line and where you have 1 4 6 4 1. So you can quickly do this to go to get your coefficients if the powers are very small. But it becomes a problem if the powers aren't that small, right? And that is where combination becomes really very useful. And then let's move to that. So if you can't use Pascal's triangle, if you have to use combination, then there's the symmetry property of combination, which also makes your life pretty easy. So you can make things very fast. Now you can already see from the Pascal's triangle, like there's already some kind of symmetry. So you can see there's 3 3, there's 4 4. So you have 3 3 4 4. And imagine if you go for the next one, right? You're going to have like 1 1 5 10 10 5 1. So you see symmetry. So you see 5 here, 5 here, 10 10 in the center like that. So there's that symmetry property, and combination can bring that out very beautifully. So, and that is to tell you that you can easily exploit n combination k, because n combination k is simply the same thing as n combination n minus k. All right. So those two work together. So exploit this reduce reduce computation. So you can use that to save your time, to reduce computations. All right. So for example, in 1 minus x raised to power 5, right? So you need to understand, of course, this is like okay, well, if we are considering this, let me just lay it bare. So you have 1 minus x raised to power 5. This is already summation from k equals 0 to 5. Then you have 5 combination k, and then you have 1. Of course, we have the general formula already, which we got the other time, because all the 1 raised power something is going to be 1. So you can just as well have minus 1 raised power k, then x raised power k. So the deal now is that you have 5 combination 0, then the coefficients. Yeah, let me just talk about the coefficients. So the coefficients are the coefficients are 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, and lastly 5 combination 5. So, but what this symmetry property is telling you is that 5 combination 0 5 combination 0 is the same thing as 5 combination 5. All right, because just like this expression has told you, this expression is simply saying that if you have 5 combination 0, it's the same thing as 5 combination 5 minus 0. Okay, so that means that 5 combination 0 is equal to 5 combination 5. Okay, so the two of them are simply 1. That's why you have 1 1 here, as you can see. So these two are the same. Then going forward, you also have it that automatically 5 combination 1 and 5 combination 4 are also the same, because 5 combination 1 is the same thing as 5 combination 5 minus 1. So that implies that 5 combination 1 is equal to 5 combination 4, and they are both 5. They are both 5, yes. Just like this is 1. So this one, they're both 5. This is 1, right? Then automatically these two are basically the same, right? Because those are the ones that will give you 10. Those are the ones that will give you 10. So each of those will be 10. So here you have, let me do it this way to make it different. Okay, let's do it this way. This and this, they are 10 each, because 5 combination 2 is the same thing as 5 combination 5 minus 2. That implies that 5 combination 2 is equal to 5 combination 3. That's always a standard, which is 10 each. And you see, that's why you have 1, 5, 10, 10, 5, 1 up there. So you can quickly, so once you get 5 combination 0, you don't have to worry about 5 combination 5, because they are the same. Once you do 5 combination 1, you don't have to worry about 5 combination 4. Once you do 5 combination 2, you don't have to worry about 5 combination 3, because they're basically the same. So you want to take advantage of that fact when you're calculating uh, coefficients like that. So latch on to that symmetry property. That makes your work very fast, so you can move on. Okay, so let's go to the third thing you need to pay attention to calculate the coefficients very quickly. The third thing would be the recursive relation. Recursive relation. Recursive relation. So here, you can use the relation, which tells you that n combination k is the same thing as n minus 1 combination k plus n minus 1 combination k minus 1. Okay, so this actually helps you. This builds coefficients. This builds coefficients step by step. This builds coefficients step by step without full factorial calculations, Okay. So a very good example of that would be something like this. Imagine if you're looking for 5 combinations, say 5 combination 2. So 5 combination 2 now uh is simply 4 combination 2 plus 4 combination 1. Okay? That's just basically the fact. So you can just build these things up gradually. So imagine if you are now if you are going to, okay, let me even do this. Okay, let me see this. So let's start with 5 combination 0. So imagine you have 5 combination 0. So this is simply telling you that 5 combination 0 is the same thing as 4 combination 0 plus okay, we can't go to 0. We can only start with 5. You already know that 5 combination 0 is 1, right? Anything combination 0 is 1 straight. So we can start with 1. So 5 combination 1 is the same thing as 4 combination 1 plus 4 combination 0. Okay? And you already know 4 combination 0 to be 1, right? So 4 combination 1 simply just tells you that you're going to the next level. So this is 1 and this is going to be 4 straight. So you can easily get 5 combination 1 to be 5, just like we've been getting all along. So that's the idea. So again, 5 combination 2 is simply 4 combination 2 plus 4 combination 1. You already have 4 combination 1 here to be 5. Okay, so you can just move on to that next level where 4 combination 2 uh can also, you can actually get to build on the same thing and just move on like that. Okay, you already know 4 combination 1 to be 5. Okay, so 4 combination 2 will be 4 factorial over 2 factorial 2 factorial. That's like 20. Okay, that's like 4 times 3 times 2 factorial over 2. So that's 10, right? So you have is it 10? So this is, yeah, this is 12, 6, like that. So this is 5 combination 2. It just tells you 4 combination 2 plus 4 combination 1 again. So 4 combination 1. Did I say this is 4? No, no, no. This is actually, this is 4. 4 combination 1 is 4. 4 combination 0 is 1. So 4 combination 1 is 4. So, I mean, this now is simply 6. So 5 combination 2 is 10. So you can build things up gradually like that. Although this may not be as useful as that idea of symmetric property. So, I mean, you just want to master it in your own way. So this is just like I said the other time, this is 4 combination 1. This is 1 for sure. This 4 combination 1 is 4, so that everything is 5. So you can use that recursive relationship. Okay. So there's also something else that we can latch onto to quickly calculate the coefficients, and that is small k approximations. So we can you make use of small k approximations. Small k approximations. For instance, if you have large n, so for large n and small k, for large n and small k, you can easily approximate n combination k to be something close to n raised to power k divided by k factorial when the k is small. So imagine, for example, 100 combination 2 is approximately 100 squared, which is 100 squared would be 100 times 100. That's 4 zeros. That's 10,000 divided by 2. So that's 10,000 divided by 2, and that will give you 5,000. Okay. So when you have big N, small k, you can easily do that approximation. All right. So, if we were to take an example, let's just do that. So imagine this example where we have to expand 1 minus x raised to power 3. Okay. That's what we have to do. And then, of course, you have 1 minus x raised to power 3, and that is summation from k equals 0 to n. I mean to 3 now, because we know n is 3. Then you have 3 combination k, then minus x raised to power k, then minus x raised to power k, sorry, minus 1 raised to power k, then x raised to power k itself, so that you now have 3 combination 0 minus 1 raised to power 0 x raised to power 0 plus 3 combination 1. Then now Okay. Uh, so we have minus 1 raised to power 1, x raised to power 1. Again, you have 3 combination 2, minus 1 raised to power 2, then x, you have now x raised to power, okay. Yeah, I think, yeah. So it's 2 now. Everything is 2 because we have eliminated 1. We are just using this formula strictly. So now you have 3 combination 3, 1 raised power minus 3, minus 1 raised power 3, x raised power 3, like this. So, of course, from what I've said already, 3 combination 0 is the same thing as 3 combination 3. So, and that will be 1 automatically. Then 3 combination 1 is 3 combination 2. So, this is 1, 3, 3, 1. Easy. So that way, and you also know that this is positive, this is positive, this is negative, this is positive, and this is negative. So all you just need to do is to put everything together now so that you just have this is everything here is okay. Let me bring it down. So now you see that 1 minus x raised to power 3 is equal to, so this positive 1, so you have 1, and then here you have negative, right? So you have minus 3x. I think we've done this before. Then this is now positive again. So we have plus 3x squared. And this is now negative again, minus x cubed. So, I mean, we've done that a couple of times, and that is how that works. So you can just go over and be sure you get this right. So binomial series still continues. We have not come to an end of this. So you want to follow up for the other videos by subscribing to the channel and hitting the notification bell. Comment. Let me know. Let me know how well these things are helpful to you. And of course, let me know if there's a problem you'd like me to solve, or a a topic you'd like me to teach. All right. Then also like and share so that other people can benefit from this. But before I go, do you want to try this practice question? Practice questions, in fact, practice questions. Okay, let me just make it 1. So try this. 1 minus x raised to power 7. So give me the solution in the comment section if you can do that. All right, so till I come your way again, keep doing maths right. Bye.